This presentation will discuss spatial analysis and geoprocessing. Now, GIS has various aspects of it that distinguish itself from other information systems. You're going to see that when it comes to the spatial analysis part of GIS, this is really what truly the major aspect of it which distinguishes itself from other systems. So let's look into that and also the operations associated with that. So now looking at the definitions of spatial analysis and geoprocessing. Spatial analysis is the study of locations and shapes of geographic features and the relationships between them. Simply put, everybody, all these features that we populate the layers with in a GIS, all that information, all those objects that are being represented within a GIS, within an environment, they exist within a three-dimensional world. And because of that, they inherently have what we call spatial relationships. Okay, at least between two objects in space, if they exist within an environment, there are relationships that exist in that three-dimensional world. And so, welcome to spatial analysis. And in the process, everybody, you're going to see that geoprocessing takes place. Operations orientated towards the manipulation of spatial data. Now, quite often, before spatial analysis is done, attribute queries are done. Now, please note, attribute queries are not spatial analysis. Sometimes they seem like it because, well, we get results that seem like, the results are actually within selecting three-dimensional objects based upon their attributes. But attribute queries, everybody, are a precursor, because before you do spatial analysis, quite often you have to identify those things that you want to compare in space and do analysis with. And there, as mentioned in another presentation, the use of just attribute queries is, without even doing any spatial analysis for quite a few organizations, is sort of a widespread practice. So, hey, why not? If you get the problem resolved without having to go too deep into analysis, sure, no reason to make things more difficult. However, though, again, please note, it isn't actually spatial analysis, and there are a variety of ways, as you can see here, when it comes to the actual doing of attribute queries, that there are different directions to go with. So, yes, attribute queries, very cool, and also a precursor quite often to spatial analysis. Now, with spatial analysis, we're going to look into spatial relationships, and you're going to see that there are three primary spatial relationships that we're going to be looking at. The first one, now this is a real workhorse of spatial analysis, proximal, the distance relationship between objects. It could be as simple as saying, by the way, how far is an object from from object A to object B, to creating some very complex surfaces, say raster surfaces, dealing with proximal relationships. So I guess you're kind of getting the gist of things, that with GIS you can do some very simple operations that are effective, but it can take you into the world of very complex analysis if you want to go there. So that's proximal. Okay, now directional, the angular relationship between objects. Now we're kind of looking at, from the where question. Okay, where is this object respective of another object in space? And again, you can take that into different avenues when it comes to GIS. Now the third one, topological, the physical relationship between objects. Now, physical, what do we mean by that? Okay, we're in the electronic world. What is physical? Well, picture this now. Let's just say that there was two parcels of land that they are, well, touching each other because, let's face it, between you and your neighbor, when it comes to property, you don't have some teeny little piece of property that is unaccounted for. No, that's seamless. In a GIS, if there's say a parcel layer, that would be a physical relationship, a topological relationship. Okay, that would mean that your parcel of land is adjacent to that other parcel of land. And okay, let's look at some other, maybe other relationships too. Say an animal's habitat, a layer that shows a polygon showing where an animal lives, and then you look at, say, for instance, a housing development that recently has been built, and you create a layer showing where the houses are. Well, the topological is that they would be intersecting each other. So you're going to see that with topological and the GIS, there's it's a game of semantics in some ways, but you're going to see that there's a lot of ways that you can frame the relationship, and so that's kind of fun. Now, what is spatial analysis all about, everybody? Ultimately, whatever you're looking at, the spatial relationships, proximal, directional, topological, what are you trying to do? It's all about data reduction in general. What you're doing is you've got a lot of data about something, and as a professional, you get to pick and choose what data is most relevant for this analysis. And by the way, please note, GIS is ArcMap is the ESRI products are wonderful products, and there's a lot of things you can do with them. But the competent user, okay, the person who's a professional in their field, extending their knowledge base, their skills using the software, that's a major component, okay. They're a plug-in for humanity, yay. But now back to spatial analysis and data reduction. What you have to do is this: you're going to start to set up parameters where one thing has to be true, and another thing has to be true, and another thing has to be true when it comes to relationships of objects in space. And then you finally start to reduce the possible answers. And so that, my friends, is what we're going to be doing. So now, how do we start this process? Well, everybody, thanks to ESRI. Okay, what great folks they are. They created the ESRI 5-step process for basic spatial analysis. Thank you, ESRI. Now, step number 1, frame the question. When you're going to do spatial analysis, quite often, if you can't make a statement, a one-sentence statement, saying what it is you want to do. Okay, if you say, I want to identify what animals are in danger because of encroachment of human settlement or something like that. You have to be able to frame the question so that way you know specifically what is it I'm looking to do when it comes to the analysis. I need to find, by the way, sorry, with that example I gave you, a more focused question would be, what areas of animal habitat are right now are in danger when it comes to a human settlement. Okay, that means that we're going to have a GIS solution to that, looking at the data, and we're going to next start taking it down the road of framing things. Now, number 2, explore and prepare the data. In this process of framing, everybody, the doing of all this. Okay, so you have the question, and you say, okay, we're dealing with animals that are in danger, and we have this layer of information. We need to know where these animals are. Okay, fine. And also, we're going to need to know where those humans are. Okay, great. And then we're going to say, hey, by the way, the hydrology is very important because these animals, they really need standing water, and so on and so forth. What you're going to be doing is, in the process of setting things up, you're going to select the most relevant data sets to complete the analysis. Now, number 3, choose analysis methods and tools. This is where the long lost art of getting out a piece of paper and a writing utensil comes into play. Or, by the way, you could typing onto a computer your analysis methods is fine too. See, I just showed you how old-fashioned I am. I want to pull out a piece of paper and a pencil. But this is what you're going to do at number 3. You're going to look over the parameters of what it is that has to happen. Okay, if you say, by the way, I have to find those places that animal habitats intersect where human settlement, right there. Okay, you say, hey, by the way, one polygon, we have to figure out what space it shares with another polygon. Okay, hey, what is the analysis method there? Hey, there's this thing called clip that we could do. All right, hey, yeah, and then you look into the, say, the help for ArcMap, and you say, yeah, you know, that seems to work out, or you know, you've done exercises, so you're familiar with that. And you say, okay, now check that off. Okay, now we know, you know, what property that humans have intersects with an animal habitat. And then, so see what you do, everybody, is again, kind of framing things, okay, flow charting things out. You start saying this has to happen, and then you look at the next parameter and you say, okay, I have to do this to figure out what's closest to that. What kind of tool do I use? This is good because once you map everything out, so to speak, once you've created this flow chart, then wonderful, you just start doing things. Now, some people like to sit in front of the computer and say, let me just kind of fish around a little bit. That's great. I mean, hey, you know, you learn a lot from just simply exploring with the GIS, but really, if you can't put what you're going to be doing down on a piece of paper, then you're really on a hunting trip or fishing trip, whatever way you want to gather the food. But you see, you're kind of going in blind, and there's no reason to do that. Now, number 4, perform the analysis. Simply put, you're going to go ahead, plug everything in, all your operations, and then finally, number 5, examine and refine results. You might look at your results and say, well, I had these parameters. I wanted to be within 1 mile of roads because they're animals that are being killed by impact with vehicles, so on and so forth. And you say, no, actually, no, 1 mile wasn't really, distance seemed right. It's too far from the roads. Let's go a quarter mile. Things like that, where you just say, hey, let me go back again maybe and refine the results, because it's it's whatever you look at by the way, of course, don't skew things to say, I want the results to be exactly what I want them to be. Like you said, I'm going to, a self-fulfilling prophecy, so to speak. No, you have to accept, of course, the results. But I'm saying is that changing parameters for logical reasons, that's fine. No problems there. Okay, now it's time to look at geoprocessing, the tools of the trade. For starters, everybody, buffers. Okay, now we're looking at proximal relationships here. Wow, buffers are really useful. So, what are buffers, everybody? A polygon enclosing a point, line, or polygon at a specific distance. What you're going to do is you're going to create a zone of distance around some feature. Now, the second pointer, excellent for selecting features within distances of other features. It's so simple. I mean, again, it's just, it gets the job done. And the best thing about it is point number 3, buffers can be saved as GIS layers. Once you create a buffer, say you want to find the area within 3 miles of a river, then afterwards you create a buffer. That buffer is there. You can bring it back in again if you ever have to do other kinds of analysis. And now here we see an example of buffering. The input here, whatever these areas are, let's just say this was zones that were, say, contaminated, and we said, oh, we got to have at least a half-mile zone around those areas that we're going to close off to the general public. And the output here, you see the buffer that was created. Now that buffer, the second graphic to the right, it is an independent layer now. But also you see that one buffer kind of merged into another buffer. And you have the option to do that. So when you're creating buffers, you have a couple of ways that you can, a couple of variations of the output that you can create. But this is a nice, neat way to do it, to set it up to where the buffers, once they start intersecting each other, they merge into, well, one big happy buffer. Now, another widely used geoprocessing operation, clip operations. Clip, to extract the features from one layer that reside entirely within a boundary defined by features in another. Want me to simplify that for you, everybody? We're going to use an electronic cookie cutter. Okay, Here you see in graphic number 1 to the left, the input. Okay, there's some environment there. And the clip feature could have been actually the result of a buffer. And you say, by the way, I only want the stuff within a certain area of that buffer. Okay, the cookie cutter effect, the clip feature clips the input, and next thing you know, your output is going to be based upon the boundaries of the clip feature. Now, moving on, intersect and union. Intersect, an overlay that preserves the features and attributes that fall within the area common to two layers. And union, an overlay of two polygon layers that preserve the features and attributes of each. Well, by the way, the progression of geoprocessing tools that are being presented to you right now, you'll see that in ArcMap version 10.3, that at the time this video is being recorded, that even from the menu in the interface, you'll see that there is a menu option there called geoprocessing, and all great English, all of these are available, very easy to access. So that kind of tells you the importance of these when it comes to spatial analysis and geoprocessing using ArcMap. So now let's look into both of these and see what we can find. Well, everybody, with intersect, you have two polygons that are available for analysis. And let's start imagining what this could be. Okay, polygon number 1, and that's the one to the right. Okay, so we're looking at the upper right. Yeah, by the way, I have arrows here. I could actually show you stuff here. This one right over here. You'll see the one in the upper left. Let's just say that was a mountainous area. And the one over to the right, again, we're looking at the graphic at the top. The one to the right, let's just say that was bear habitat. And we were wondering, gee, I wonder what area do bears live within a certain mountain region. And by the way, maybe the rest of the mountain range is much too rugged for the bears to move around in, so that would explain that. Now with intersect, everybody, what happens is down at the bottom you see that highlighted polygon between the two. That is a brand new polygon, and in the intersect layer, the other two polygons, the original ones, they vanish. What you're going to get is that sliver that was created by the area where both of them intersected. Now you might be asking yourself, so what's the difference between intersect and clip? I mean, didn't it kind of like just clip something out right here? Well, yeah, it did. However, though, when it came to clip, when one object kind of decides the what's going to be removed from the area of another one, the original layer, it's going to the input layer. It's the attribute table is just that. There's not going to be any more additions of fields from other layers like that second layer that did the clipping. So what's the big difference here is this, is that with intersect now, you're going to see that that new polygon is created through the intersection of the two. You're going to find when it comes to the attribute tables, you're going to find those fields are suddenly going to be in that that new polygon. Now, I say, hey, that's great. Now we kind of merge things together. Sounds pretty good. Now, for the most part, maybe there's going to be most cases where that's not going to be a big deal. Like for instance, if well, not to go into big details there, but what if, okay, when you're looking at this the scenario here, and you say, hey, now we found this area where the bears are within the mountain region, and in the original bear layer, I hate to say that, but the one to the right, let's just say there are 500 bears in the attribute table. How many bears are in that polygon? 500. Great. Okay, you intersect and you create that new polygon. It's going to take those fields, again, the original fields, and it's going to bring it into that new polygon. Unless you manipulate the result, okay, I actually tweak it. By that I mean there's actually ratio operations that you can set up so that way, or parameters, so that way it will reduce the value in a certain field based upon the change in area. Guess what? That little sliver of land is going to show 500 bears. I mean, it's going to be like bear mountain. I mean, like imagine 500 bears suddenly in that smaller area. So just be careful that when it comes to intersect, and also, by the way, the next thing we'll talk about union too. You have to consider, in my fields, fields are going to suddenly start to be put into new polygons. Are those new polygons, since they're going to be smaller or maybe even larger, does that change the value of a certain field? So please keep that in mind. And with the union, the same aspect dealing with ratio and attribute tables. Please keep that in mind. But now for the union here you see 3 different polygons, and who knows, maybe again there's just geometric shapes here. But let's just say the rectangle was say some environment, environmental data. This and the circle to the left, let's just say that was human settlement, and the circle to the right, let's just say that was temperature data or something like that. Anything like that. Well, once we go through union, suddenly everybody, you're going to see that there's going to be several new polygons are going to start to be created. So it's sort of like you're splitting the boundaries, and in the process, creating brand new polygons along the way. And again, just be wary of the changes to your attribute table. And 2 more widely used geoprocessing tools, everybody. Merge and dissolve. Merge combines multiple input data sets of the same data type into a single new output data set. And dissolve creates a new feature by merging adjacent polygons, lines, or regions that have the same value for a specified item. Now, what we're going to be doing now is a little bit of data management here. So let's look into merge. Now, by data management, what if you had, say, in this example here, you see 2 different layers that suddenly they become one big happy layer. Let's just say you were doing a study of different parts of the different regions of the United States, and you had one layer that showed the Midwest states. You had another layer that showed the Atlantic states, another one that showed the Northwest, and so you had all these bits and pieces of the country, and you created them as separate layers, and you said, gosh, I wish they were all just together in a layer called the United States. Why do I have them all separate? Well, welcome to merge. What you do, everybody, is you take the different parts, so to speak, of like features, and you're going to be able to put them together into one layer. Now, by the way, it doesn't have to be just polygons. It can also be points and lines. So that's merge, everybody. So it's really quite simple. You just have different layers of information, and they again similar feature. Same point. They're all point. They're all line. They're all polygon. You're not mixing them all together into one big happy layer. But if you have polygon layers, again, like I was sharing with you about the example of the United States, you merge it together, and then you would have a layer that you could say this is the U.S. states, by region or something like that. So that's merge. And now dissolve, another very useful tool, in that quite often we don't need to see the forest. What am I talking about? We must be a long video. We do want to see the forests, okay? You don't want to see the trees, okay? That is what I wanted to say. And so let's just say we had, so for instance, in the graphic over to the left, you've got a bunch of polygons, and let's just say that this is a forestry layer, and you're looking at different types of trees. Let's just say that for every, see there's oak, there's pine, and there's spruce, represented by each one of these different colors, and who knows why they were separated into the smaller polygons. Well, after everything is said and done, you realize, hey, I just want to have, in general, those general tree types in an output coverage. Simplify that the graph or the feature output. So you dissolve, and you say, okay, dissolve by what? Dissolve by tree type. And what it does is it starts to remove those boundaries between different polygons based upon like attribute qualities. And, well, just to summarize, when it comes to spatial analysis and geoprocessing, once again, some very simple tools that are used in many different ways, and they're effective. And so, go for it when it comes to learning these, because you're going to see you can do a lot with them. But again, when it comes to being a GIS professional, when it comes to spatial analysis, there are scientists and engineers all over the world that they take this information system to whole new dimensions when it comes to the things you can do with it. Thank you.